All right, in our last video for section 3.6, we're going to talk about parallel and perpendicular lines. Think about two parallel lines. Here's an example. What do you notice that's the same in parallel lines? Their y-intercepts are a little bit different, but if you notice that their slopes are exactly the same. And if you tilt them, no matter how you tilt them, as long as they're parallel, their slope should always be the same. That kind of makes sense, right? And so I know now that anytime I have parallel lines, their slope should be the same. Or if I know that two lines have the same slope, then they're going to be parallel. If they have the same exact slope, two lines are always going to be parallel. Makes sense. So what about perpendicular? What if I have two perpendicular lines? Remember that perpendicular lines always cross at exactly a 90-degree angle, a right angle. Their slopes are definitely not the same. But what are they? Well, perpendicular lines always have slopes that are opposite and reciprocal, or negative reciprocals, you might hear. What I mean by that is if one of the slopes of the line was 1/4, then the perpendicular line to it would have a slope of -4/1. They're opposite, one positive, one negative, and the reciprocals of each other. Pretty cool, huh? Well, I found a cool video in YouTube that kind of gives you a visual representation of why that is. You might want to take a few minutes and look at it so it'll kind of make even more sense. Opposite reciprocals. They have to be both. It can't just be one or the other. But if two lines have opposite reciprocal slopes, then they are definitely perpendicular. They cross exactly at a right angle. All right, let's think of two vertical lines. Imagine two vertical lines. Well, two vertical lines are going to be parallel to each other, right? Always. Or two horizontal lines. Two horizontal lines are also going to be parallel to each other. Well, if you think about then a vertical line and a horizontal line, they're always going to be perpendicular. Do you remember what the slope of a horizontal line is? 0, right? Or can I say 0/1? Do you remember what the slope of a vertical line is? Remember that a slope of a vertical line is actually undefined. Well, what is the opposite reciprocal of 0/1? Well, it would be -1/0, and we know that we can't divide by 0, and that's how we got the undefined. So it makes sense. Vertical and horizontal lines are perpendicular to each other. They have negative reciprocal slopes, opposite reciprocals. So let's kind of use those two ideas of parallel lines having the same slope and perpendicular lines having opposite and reciprocal slopes to figure out if two lines are going to be parallel, perpendicular, or neither. Neither meaning that they cross, they just don't cross perpendicularly. So if I give you these two examples, example number 7, A and B, and ask you if these two lines are parallel, perpendicular, or neither, you could try to graph them and then look at their graphs. But I don't know if that's very scientific or mathematical, because what happens if they look perpendicular, but they're not exactly perpendicular? Maybe your angle isn't a 90-degree angle, maybe it's like an 88-degree angle. It might look perpendicular, but we don't know for sure. We won't know for sure unless we look at their slopes. If we know their slopes are exactly the same, well then I know they're parallel. If they're opposite and reciprocal, well then I know for sure that they cross at a 90-degree angle and they're perpendicular. So let's look at that. Let's take these two equations in example number 1a and see if we can find their slopes. And if they're the same, I know they're parallel. If they're opposite and reciprocal, I know they're perpendicular, and I don't have to graph them. So how are we going to find the slope of these two lines? Well, remember from our last video that if we can put any linear equation in slope-intercept form, y equals mx plus b, we can quickly pick out the slope and then compare them and see what type of lines they're going to be. So let's do that. Let's take the first equation. Let's put it in slope-intercept form. So I'm going to subtract x to both sides. I ended up getting the equation y equals -x plus 5. So what's the slope of this line? Remember, as soon as I can get it to look like slope-intercept form, the slope will be the number in front of x. So in this case, there's really just an invisible -1. So I know that the slope of this first line is -1. Let's look at the slope of the second line. Taking that second equation and making it into slope-intercept form, I'm going to subtract 2x to both sides, and I end up with an equation of y equals -2x plus 5. What's the slope of this line? I got a slope of -2, did you? Now, I don't really care right now about what the y-intercepts are. All I want to do is look at their slopes. The slope of the first line is -1, The slope of the second line is -2. Now they're both negative, but they're not the same exact slope. So these two lines are not parallel. In order to be perpendicular, they have to be opposite, one positive, one negative, and reciprocals, and they're not that either. So these lines are not parallel, they're not perpendicular, they're neither. They would just cross, they just don't cross perpendicularly. All right, let's look at B. Can we determine if these two lines are parallel, perpendicular, or neither? Let's use the same process. Let's put them both in slope-intercept form, y equals mx plus b, and let's compare their slopes. Hey, maybe you can try it. Pause the video, take a few minutes, do that process, and let's see if you can tell if they're parallel, perpendicular, or neither. All right, for the first equation, I'm going to go ahead and divide every term by 5. I ended up getting the equation y equals 2/5 x minus 3/5. Now, all I'm worried about is the slope. I don't really care right now about the y-intercept unless we needed to graph it. But if I'm just looking to see if they're parallel or perpendicular, I just want to look at the slope, which in this case is 2/5. Let's look at the second line. Using the second line, I'm going to go ahead and make it look like slope-intercept form by subtracting 5x to both sides. I ended up getting 2y equals -5x plus 4. I'm going to divide every term by 2, and I ended up getting the equation y equals -5/2 x plus 2. So what's the slope of that line? Well, it looks like the slope of this line is -5/2. If I have a positive 2/5 and a negative 5/2, they're not the same, so they're not parallel. Are they opposite and reciprocal? It looks like it. So as soon as I see that they're both opposite and reciprocal, negative reciprocals, I know that these two lines are perpendicular. I know that they cross exactly at a 90-degree angle, not just by looking at them, but by comparing their slopes. Remember, parallel lines have the same exact slope, and perpendicular lines have negative reciprocal slopes, opposite and reciprocal.